here. First off, just you'll note that there's even though I say I'm recording, there's not going to be a dot indicating that I'm recording, and this is because I am not using a Zoom to record. I am using OBS, which is what I normally use to record, because I actually before this pandemic recorded all my lecture. They are all on YouTube, all the previous semesters if you want to peruse them. But for this class, that's not too helpful because we're going to be using the same lectures I would use anyway for this class. I guess I can remove that since I am here, and now I should probably be a bit more enthusiastic. So, there. So, I'm just using this to record, and I'll upload, like, any pertinent stuff to YouTube. And let me just show you. It was linked in the first announcement, but I have a second screen. That's where I pulled that from. So you'll see me doing some magic occasionally. Hold on. I just really need to know now. If I use, how does that work? So task view, new desktop. Does it screen share? Ooh, it does. Nice. Okay, that will be useful later on. Okay. Sorry, I always think of new things on the fly sometimes. So, always sometimes. Great. Okay. So, I'm still just wasting some time because I'm still waiting for some students to show up. They're slowly trickling in. Yep. Okay. So, over here, right, in the announcements, I'll be sending out announcements with links to the class when it's time. I will I can either schedule them in a certain meeting, I can schedule like recurring meetings and stuff, and so that you would click on it. But honestly, I prefer to use the same link to join. Students find that easiest. So, we'll probably go with that unless I find a need to do it otherwise. Pages is actually a very important location in this. Under Pages, we will have, so first off, Crash Course Data Structures. This is a YouTube video done by Crash Course. It's a 10-minute overview of pretty much everything you're going to learn in this class. It's very nicely presented. Crash Course, if you're not familiar with them, they're wonderful. They're a wonderful YouTube channel with all sorts of topics, ranging from world history to biology and a bit of computer science topics. The computer science topics ones, they go over high-level programming topics, and as well as low-level. So so like operating systems and the way computers actually work, without actually going into any programming whatsoever, which is really interesting. So, next, all the code that I've done can be found on GitHub. And this is my GitHub repo for all the code that I've done for the class. I don't update it too often for data structures because I don't need to type much code because I've already typed it up, as you'll see in the videos. So, next, in-class recordings, that's where I'll put stuff like this, where that gets recorded. It's also got the in-class recordings from the last couple semesters. Note that these are playlists, okay? So a lot of what I post on the pages are playlists. So you either want to click on this to go to YouTube, or click over here to bring up all the videos. Make sense? And finally, this is the most important one of them, lectures, where you'll find the various lectures. So under normal circumstances, this is a flipped classroom. It's still going to be a flipped classroom. And I'll get into what that means in just a second. But from what I did, so I taught this back in the spring when we had to switch from being in person to being online. And my students basically said that this was one of the easiest classes they had to deal with during the pandemic because it basically was no transition whatsoever for them. It was it was super easy. They were already watching their lectures online, and they were already doing what they need to. All right. So, a flipped classroom. What that means, it's a pedagogical method, and the idea here is that it's the kind of the insight is that like the method of delivering the standard method of lecturing is actually not that smart. There's nothing wrong with it, but it's not optimal. And what we mean is that basically we expose you to your information during lecture, right? I teach you things during lecture, and then I tell you go and do something with that. So and then you go and do your homework, and then you were wondering, well, it made sense during the lecture, but now I have no idea what I'm doing. And in computer science, that often means like you bang your head against the wall for 3 hours in a row, and then you figured out you misspelled print as pint. So and it's just often like small errors like that basically if you brought it to me, I'd be able to fix it in 3 seconds. Now, why can I fix your error in 3 seconds? It is not because I am some uber genius computer science prodigy. Far from it. I'm actually... I feel like I'm a decent programmer, but I know I'm not the best. What I am good at is detecting errors, because I have made so many mistakes. And that's really what the difference is. When you are a programmer, you learn by making mistakes. I mean, that's true of anything, but... what I'm talking about here is that basically you make an error, you'll try to fix it, have no idea what you're doing, and then you'll finally fix it. And next time you make that error, you'll be like, oh yeah, I fixed this before. So not only have I made this error, but I've seen hundreds of students make the exact same error. So I can fix them really quickly. And that's why, so it's not necessarily because I'm like smarter than you or something like that. It's that I've failed more. I've had more opportunities to fail. And the reason I bring this up is because one of the things that happens in that once you get to the point of data structures, right? Imposter syndrome really can start to set in. Is anybody familiar with imposter syndrome?
Yeah.
Yeah. Do you want to share what that is?
It's when you feel like you haven't earned the success that you had.
Yeah, that's a big component of it. It's called that because you feel like an imposter, right? And you feel like you're just winging it, whereas everybody else around you, they know their stuff, obviously. Otherwise, they wouldn't be here. And it's actually that everybody kind of feels that way. It's kind of the reverse of Dunning-Kruger, which is the psychological phenomena of like, is basically saying if you are incompetent, you do not realize how incompetent you are. So like if you think you might think that you're funnier than you actually are, or you might think that you're basically you know so little about a subject area that you're not able to make a good argument, you don't have a sense of scale as to what you can do and what you can't. So, so basically imposter syndrome is a big thing around this period of time. And so you might feel like you're being very stupid. You're not. So, pulling this back to flipped lectures, right? Why make you waste 3 hours of your very valuable and very not available amount of time during a summer semester, right? So it's even more important during the summer semester, when instead, I should probably be more available to you when you're working. So here's the idea. I assign you lectures, and here they are, right? Here's a bunch of playlists. So basically I've sorted these by, these would be essentially on almost a week-by-week basis during a normal semester. And I'm going to figure out the schedule today. For Monday, you'll want to watch this first playlist, although it may not be necessary if you just came out of 1068, because you probably know most of this stuff about inheritance and polymorphism. But basically, you watch these lectures, and you'll notice that some of them are actually very nicely designed. like this one.
That interact with each other is called an object, and we write them by defining classes.
So I'm not actually that great at developing videos like this. What happened was is that I also teach a online course called 5016, which is a graduate version of for our IS&T, and it combines 2168. Combines 1068 and 2168 into one class. So it's really accelerated. But the nice thing is that basically because there was so much 2168 content, I was able to pull a lot of stuff that I use in 2168 over to this class. The first videos, these review videos are older and they're kind of meh. But you'll notice that basically as we go into lists and Big O overview that my videos became way more professional.
Let's start by taking a look at...
So, they and I've divided them into, like, as you can see, 5 minutes over here, 2 string over here.
All right, so let's fix that 2 string.
3 minutes. These videos will range anywhere between, a couple minutes long to 15 or 20 minutes, depending on it. The normal way that this class would work is that basically, and the way it's going to work here is that you watch the lectures, and then you'll just do, and then rather than me lecturing during the lecture period as I'm doing now, you work on assignments, which we'll start doing shortly, by the way. I will let you know, like, the schedule at which you need to watch these things. For right now, try to watch the first 2. And it might sound like a lot of video watching. I think I said in my announcement that in total you can expect, between the lecture time and the video watching, the time you spend in class and the time you spend watching videos outside of class, you can expect somewhere between, like, 16 to 20 hours on maximum a week, which sounds like a lot, except remember, you're compressing this semester. Normally what happens during the semester is that you watch a playlist a week, which is about anywhere between an hour and a half to 2 hours. And then you would come to class and you'd work on the homework in class. And that's the idea. I'm here during this period to help you with the homework, so that you are able to, get through those issues that you are normally having. Does that make sense to everybody?
Mm-hmm.
And if you're and please use the chat function if you have any questions. I will read the chat function. I find that very helpful. I also am aware that this is an early morning class. I'm going to be up. I mean, I've got a toddler and I'm a night owl, so, I'll be there suffering just alongside you. But the idea here is that the lectures, you're going to be responsible for watching the lectures. Please today watch the object-oriented and try to watch the one about array lists so we can get started on that. It's going to be a bit of a hit the ground running in the case for that stuff. But the object-oriented stuff, if you find, oh yeah, I know this stuff because Professor Fiore is awesome at this stuff, at that, then you can just continue on with that. So any questions about how the course is going to work?
Do you know whether Proctorio plays nice with Linux?
That is an excellent question that I endeavor to find out. I hear it does. You just need a Chrome browser.
Yeah.
Okay, so that's what I hear. I'm going to be experimenting with Proctorio. So your first exposure to Proctorio will not be during an exam. What I'm gonna try to see what kind of unobtrusive settings I can use for it. Because supposedly it uses machine learning rather than somebody actually monitoring you. So I'll be interested. Last time I just simply monitored via Zoom, and I think the temptation to cheat is just a bit too great. Even though I did make it open node and open internet and stuff. So we'll see. But we'll see what we can do. I'm gonna look at various options. I'm just trying to find, because full disclosure, most of the time I use Linux a lot too. So I'm very, mindful of, like, privacy issues and that kind of stuff.
Yeah.
So let's see. Speaking of exams, you'll have 2 of them. They'll be online. And I might. It really depends on how we decide to do this. Like, the first exam is generally considered tougher than the second exam, but we'll see how it translates to online. I find that online programming exams are harder. Not because I like up the difficulty because you can now have access to Stack Overflow. It's more like, oh God, that I've got a compiler error and I'm not sure why, and now I need to fix that. If you were doing that on paper, I'd take off a point if I noticed it, and you would just continue on with your exam. You know? Like, there's this kind of, I need to fix everything kind of attitude during that. So, the other thing so let's talk about assignments. Occasionally we'll have quizzes, but I think the way I'm going to do quizzes this semester is I'll just simply tell you that there is going to be a quiz that I've posted, and to take it by the end of the week, please, or to take it sometime by the due date I post, please. Right? So take it on your own thing. Quizzes are only like a small portion of your grade. They're mainly self-checks. So basically just saying, hey, are you keeping up with the material? Are you comfortable with it? Right? So your final is 25%. Each of the exams are 20%. The assignments are 25%. And then the quizzes make up the remaining 10%. And these are pretty low stakes quiz. Like, I generally throw you even some free points just for taking it. Okay. Now, the way assignments work is that you do them and then you demo them. You can demo them during the class period, or you can send me a message during one of the class days to, for morning or evening, to have a private session so you can demo it. The first assignment is a review assignment called Fox and Rabbit. I've been using this one as the first assignment for a while, and people love it, so I see no reason to stop using it.
Oh, I think I've come across this.
Yeah, most likely. I find a lot of good assignments that other professors have done, and then if I can, I use them. So there's a number of good assignments. Some of them I've come up with myself, some of them I modified. This one's very fun. I also highly encourage you to work in groups. By the way, if you haven't seen it yet, you should join the Discord. You're fully able to chat with other students. There's a channel specifically there for 2168. There's a bunch of other people there too. They're just simply all the other people who have joined from my previous classes. And they may or may not use it, but, we do have I found that students on Discord are a lot more casual than they would be on other platforms, so that's why I've kind of used it.
Question about Discord.
What?
I have a question about Discord. I think the link that you sent us was like a temporary invite or something, because I always end up getting kicked out like after the 10 minutes that you originally can't speak.
Interesting. Okay, so that's weird. That is weird. That is
It's set up as like a temporary invite. Like, if I know that's an option, I don't know if that's checked off.
No, I can send. Let me go ahead and send the link in the chat. I think I ticked grant temporary membership. That must be the issue. Okay. Yeah, so here is a never expiring link. Generate a new link. Yeah, I must have just accidentally ticked an option that gave it temporary. So here it is in group chat for everybody. I'll send it out as an announcement as well. Announcement. There we go. Boom. Hey, look at that. People are joining. Okay. So there we go. So sorry about that. Thank you for bringing that up. I am not infallible. But I found that students are generally a lot happier when they can chat. and do things like that. All right, so let's go ahead and talk about the homework assignment and just hit the ground running, I guess. Right. Oh, and be sure to read the syllabus. I don't feel like I need to waste their time with that. So Fox and Rabbit, let me download the PDF of it. I'll help you get it set up if you need to. And then we can either pair up. You can either pair up with somebody you want to, or I can just simply randomly assign you in groups. So this is a review of 1068. So it's got so you'll see that there's a visual component to it. Let me go ahead and boot up IntelliJ. Actually, I don't need to boot up IntelliJ, I don't think. Let me go ahead and download it and just show it to you. Yep. Yep. So let's go ahead. I'm just going to drag it to my desktop and make it all messy. Alright. Alright, let me turn off Discord so we stop getting the dings. Okay. So let's go ahead and run. So to run this, you're going to want to extract them all to the same folder, and you're going to want to run Rabbit Hunt. I'm not going to bother booting up an IDE because that's overkill for this guy. Okay. Unless I need to, but we'll see. Generally, Visual Studio Code is good enough for this stuff. So, enable. Okay. Run it. There we go. Model cannot be resolved into a type. Let's see. How do I run this? Java. Rabbit Hunt .java file not found. Rabbit Hunt. Oh, right, because it didn't open me in that right window. CD desktop Java Rabbit Hunt. Sorry. Here we go. Compile, and now generate a bunch of class. I'll just delete those all when I'm done with the lecture. Java Rabbit Hunt. Really? What is going on? Rabbit Hunt has... How weird. Okay. I guess I'll just throw it into IntelliJ, I guess. I just didn't want to do this because... Oh. I guess it loads fairly quickly on this computer. Huh. Alright. Let's go ahead and throw them into... Let's go ahead and throw these all... So what you're going to want to do on an IDE, which is what most likely what you're going to be using, is take your files and throw them into the same folder. Right? It's kind of important that all the files get there. So Control C, and then just simply place them into the SRC folder. Right, and you're going to want to do that no matter what you use. Okay, yeah, I haven't used IntelliJ in forever. Sorry, on this particular computer, this is a new copy of Windows on here, so let's go ahead and settings. Let's make this actually easy to read. Font. Use custom font. Yeah, go ahead and up the UI to 16. And then editor. Sorry for taking a bit on this, but I do care about Fira code. Use Fira code, enable ligatures, font spacing, and now we're going to up it to 28. Apply. Because, you know, I don't want you to be having to squint at this. Okay. So now, let's open this up and go to Rabbit Hunt. That is what you'll want to run to see the our code. All right, there we go. So you get something mostly like this that's blank, let the hunt begin. It might not be blank on your computer. It really just depends on the version of Java you're using. So you'll hit run. So here is the program. So the red dot is the fox. It is a predator. It has one objective and one objective only, to feed. It does so by hunting after that brown dot, and it has done so successfully. The fox eats the rabbit after 25 turns, that brown dot being the rabbit. As you can see from me hitting reset, the board is automatically generated. The red dot is our fox. The brown dot is our rabbit. And these are our bushes, the little green things. The board, so this is not a Pac-Man style board, by the way. So the top of it and the bottom of it and the sides, those are walls. It cannot go, this is a bounded space. The fox and rabbit cannot go outside the bounded space, and it does not wrap around. It is, bounded. Okay, now the bushes block line of sight. That is an important kind of aspect here, which we'll be talking about. So the fox has a fairly intricate algorithm that it works off to find the rabbit. And it basically is something you can look at. So what the objective of the game is as follows. The fox will wins the round if it eats if it eats the rabbit. And the rabbit wins if it can go 100 turns without being eaten. So your objective is to write, I'd call it AI, but really AI is a bunch of if statements. So write a bunch of if statements that will help prevent the fox from being eaten.
Eating the rabbit?
The rabbit from being eaten, yes.
It would be quite strange if the fox was eaten.
Right, it would. So here is there's really only one rule, and the rule is that you can only modify the code in Rabbit, which I'll get to in a second. So you can look at the fox's code. I strongly recommend against taking a lot of this code and trying to reverse it. This is predator code. This means that basically that it's something that the predator, it's much more complicated than what the prey needs to be. You'll see that basically it's got its instance variables. It's got a constructor. The constructor just simply says this is where he goes. You don't need to fill those out. The decide move is basically it says how am I going to decide where to move. Okay, and I'll go over this in more detail in a second. But basically notice what it does. It says, hey, I'm going to look around for the rabbit, and if I see the rabbit. Now you'll notice that now this is have to probably go over this sometimes. You'll notice that I've got this fat equal sign over here for double equals. This is because of my font ligatures. You'll also know that there's an actual, honest to God, less than or equal to sign in the code. It's just a less than and an equal to sign. What I've done is that my font is nice and special, and when it sees a less than and an equal sign, it combines them. Which is really nice in my opinion. But some people love it, some people hate it. Some people think it's the worst thing ever.
What's the font called?
Fira Code. It comes pre-installed with IntelliJ. It was developed by I think it's an open font because I think it was developed by Firefox. Or no, it was forked off of Firamana, which is a Firefox font. So, anyway. So let's take a look at our very complex rabbit code. Okay. Rabbit. Constructor. No need to mess with that. Decide move. Return model.min, model.max. So, model.min, if we hover over it, or if we go and control click, min direction 0, max direction 7. I'll go over directions in a second. But essentially what it's saying is that the rabbit code, the rabbit's just choosing to run, its algorithm is choose a space at random, move there. And by the way, if the rabbit chooses a space it cannot move to, or if if you decide to move to somewhere you can't, you will just simply not move. So notice that the rabbit is just simply moving around at random. And at random is effectively, random is effectively 0. You can also up the speed of this, right? Simulation. Right? So, let's see. So the grade for this, by the way, is determined by running the grader. You can, the other exception is you can up this number of trials to like 3,000 or 300 or whatever. But if you run the grader, it will silently play a bunch of games and it will tell you the rabbit escaped 0 out of 300 times or 0%. And then it says this is your grade. So your grade on this is going to be 20 points. So it's out of 120 points this time. Your grade is the square root curve of your survival rate. So the square root curve is take what your survival rate is, give me the square root and multiply by 10. So for instance, if your rabbit survives 64% of the time, square root of 64 is 8. Multiply by 10, that's an 80. So you need to have a 64% survival rate to get a B on this. To get an A, you need to have a 81% survival rate or greater. Now, let's go ahead and I want to show you very briefly the difference between predator and prey code for a second. So here, what I'm going to do is I'm going to return, rather than returning a random direction. So first off, a rabbit is an animal, which means that we can grab anything from the animal class. But also we will rely on this model class. And I'm going to spend probably most of this lecture just talking about this. And I'm going to figure out our schedule, because I assume that basically the lab session on tomorrow will be taken up by plenty of this time. So we've got a bunch of static variables in here that are private, so you can't mess with them. So let's take a look. We've got min and max, and then we've also got stay. So there's 8 cardinal directions. So, and it goes around clockwise. So 0 is north, northeast is 1, east is 2, southeast is 3, south is 4, southwest is 5, and so on and so forth, right? So, however, that can be a bit hard to remember. So instead we just have, we have all these abbreviations there. And then we also have min direction and max direction, right? So I'm going to just use return model.stay. This means that the rabbit survival strategy is as follows. Don't move, which is actually a survival strategy some animals use. And look at that. We went from having a 0% survival rate to a 1% survival rate. Not much of an improvement, but an improvement. Now this gets into whole concepts about why that is, but let's take a look at the Fox code to understand what's going on. Now, what's with the whole model, view, and controller thing? So this is a old school graphics paradigm, where basically we have 3 different things going on that describe what's the program. So we have the model, which is the internal view you cannot physically see. Like it's all the internal rules, the internal logic. This window over here, where we see everybody moving around, that's the view. It gets updated as the model gets updated. Right? So basically you update the model, you update the view. Okay? The controller is literally these buttons over here. It's the way you can interact with something. Okay? So, really, it's not important for you to check the controller or the view because that's just graphics. Same with the rabbit hunt. What we really care about is the model and the rabbit. So, and I'll mention this. One very useful thing we should mention over here is the function turn. And that will prevent you, and I'll go into this a bit more, but you can read the documentation, but its purpose is to prevent the whole, well, what if the fox is to the north of me versus what if the fox is to the south of me or the northwest of me, right? Basically, you can turn all your absolute directions into relative directions using this. So, let's go ahead and take a look at the fox and the way it works. So, the fox, he decides his move by basically asking, can I see the rabbit now? And then what he does is that he does this loop. This may be the only thing you want to grab out of the fox's code, which is that he says, I'm going to look in all the directions. Okay? If look I equals model.rabbit. Model.rabbit being the variable for basically, so what look does, so you have two functions for seeing stuff. The first is look, which says, given a direction, it will return the first thing it sees from that direction. So it will return either a rabbit, a fox, a bush, or a wall. Okay? It says, okay, look north. What do I see north? What's the first thing I see north? And look south. What's the first thing I see south? It's saying, if I see the rabbit, then what am I going to do? I can see the rabbit and have seen the rabbit. Those are both true. And then I say, set the direction to the rabbit equals I, and then I keep track of the distance. This is actually way too much. This is more than what you probably need for the rabbit. Or rather, let me rephrase that. The rabbit if you want to get a high B, low A, then really all it needs, the rabbit needs to do is kind of have a basically, do I see the fox right now kind of deal. Anything above that if to get higher survival rates is a bit more complex. So anyway, what the fox does is that he uses the distance function, which says, given this direction, I, how far away am I from it? Doesn't know what it is. That's what the look function is for. Distance just tells you how far away you are. And then what it does is that after it figures that out, it says, hey, if I have seen the rabbit, and I'm not at the last known location, so my distance to where I believe the rabbit is greater than 0, then I subtract the distance and I move in that direction. Otherwise, I got to the spot the rabbit was at, so my distance is there, but I've somehow lost him. So I can't see him anymore, and so I return a different direction. And start random, and return I set my current direction to be random. And now what this code does is not really relevant for you unless you want to go and figure out how it works, but what it's going to do is that we can observe that the default behavior of a fox is to pace. It doesn't really randomly move. It makes a circuit of some kind, right? So here it's pacing diagonally until it saw the rabbit. The fox will just simply... I'll be there in a second, Laser. And so now it saw... So it's going to pace back and forth. If it doesn't see it, it will run away. So here is a good kind of first step for you guys to kind of work on. Okay, what you want, your objective for today, I would say, is to do the following: get this set up, get it running, okay, and then get it to the point where you can see the fox, and if you see the fox, move directly away from the fox. Now, this is not going to work for very long, because if you're moving directly away from the fox, you're eventually going to hit a wall or a bush. And then you can't move directly away anymore. And then you get eaten. And then it's game over. Right? So do that. Otherwise, so if you see the fox, move directly away from the fox. Otherwise, stay put. Now, and then once you get that working, that's really the scaffolding you need to make to get a strategy that will work like 100. That will work not 100% of the time, but somewhere between, on the low end, 70% of the time, and on a high end, like 90% of the time, depending on how you set up your conditions. Now, there are two general strategies that you have here. Strategy number 1 is to abuse line of sight mechanics, which is, let's just talk about this for a second. Right? So I'm going to use the step function. So here we can see it will draw the look function. So if you notice from this, there are actually huge gaps in the fox's line of sight. Right? So here, give me a second to annotate. So here is one direction. Let's see, boom, 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 that it can see in. Okay? And here's another direction it can see in. Look at this giant cone of blindness that the fox can't see. So strategy number 1 is to abuse the fact that the fox is essentially blind in this cone. Okay? So are you, but you're not looking for somebody. You're just trying to keep away. Right? The fox needs to find you. The next is that basically that these steps that happen it's asynchronous. So the fox looks, and then it moves. So it's possible for the fox to move, to look, not see you, move, and then suddenly be within line of sight of you, but not know it. Then it's going to be your turn. You look, you see the fox, and then you move out of the way. That's strategy number 1, which is evade and abuse line of sight mechanics. Strategy number 2 is for those of you, which is a bit tougher, but can be more satisfying, and it's for those of you who are familiar with MMORPGs, which is to use the kite strategy. And for those of you who are not familiar, that's just simply where, if you're in an MMO, the idea here is that one player, the tank, who has a lot of HP, will generally run up to a monster, shout in its face, and say, "Eat me, sucker!" And then if you're trying, and then he'll either stay still while everybody else wails on it, or they'll kite it, which means where basically he says, "Eat me, sucker," and then he runs away and basically abuses the terrain to avoid taking damage. So in this case here, the terrain is bushes. So it's possible if you know your terrain and you know where the fox is, then the fox is always going to be following you, and he follows a very straightforward algorithm. You can essentially lock the fox into an infinite loop chasing you and then run out the clock because you guys are running at the same speed. So those are your 2 strategies. Any questions so far?
No.
All right. Would you like me to go ahead and separate you guys out into breakout rooms so that I can jump between each of you guys pseudo in groups?
Okay.
All right. So I'm going to just randomly assign you guys because why not? You'll want to use the share screen function. So let's see. Breakout rooms. There's 14 participants per room. Yep. And we'll create the rooms. You're going to be automatically moved into those rooms, and they're open. And I'll go through the rooms in order. Okay. And I'll be there in a second. I'm just going to check on my kid. Hey, Laser. You need anything, Laser? You can eat your banana bread. It's right there. Okay. Okay. Good morning. So, while we're here, why don't you guys tell me a bit about yourselves? If you're speaking, I can't hear you.
Can you hear me now?
Yes, I can.
Hi, how are you?
I'm doing good. How are you? So, So, do you have an understanding of what we want to do today?
So basically, Professor, we have two